So, we are going to be digging in and fine tuning your understanding of weather maps. So, if we take a look at weather maps, the first question that we're going to have for you guys that I really want you to take a look at is how can you use weather maps to explain global weather patterns and their influence on local weather? So, we're going to look at looking at weather maps and the patterns that we see and how does that influence the weather that we have here in Canyon City or in other local places? And then how can you interpret high and low pressure area as well as fronts on a weather map? So being able to identify and interpret those fronts on a weather map. Okay. So the first thing we're going to take a look at is we're going to take a look at atmospheric pressure or air pressure. Okay. And so we get atmospheric pressure caused by the weight of air above an area. So gravity is going to play an impact on it. So 1 square inch column of air is exerts a pressure of 14.7 pounds. So as we go higher in our height, we don't have as much pressure being exerted on by gravity. So the air pressure is going to decrease the higher we go above Earth. Okay. And again, we talked about this. A 1 square inch column of air is 14.7 or 14.7 pounds. This is measured from sea level to the top of the atmosphere. Okay. So starting at 0 feet to the top of our atmosphere, that's going to weigh about 14.7 pounds of air. We can measure air pressure by using a barometer and millibars or inches of mercury. Okay, so this is important. So when we talk about the average barometric pressure, it's going to be 29.92 inches of mercury or 1,013 and 25 hundredths millibars. And so as we have air pressure that comes down on our barometer, it's going to cause pressure or cause mercury to rise into the mercury barometer. And then that's where we get our scale from. So we can use it measuring mercury. The amount of pressure that's displaced in the reservoir pushes up through the tube, and that's how we get our reading of mercury. Okay. When we have high pressure, so a high pressure system, we're going to have greater pressure on the barometer. Our number is going to be higher. So 29.92 is going to be the average pressure. If we have high pressure, it's going to be between 30 and 31 inches of mercury. If we have low pressure, it's going to be less pressure on the barometer. And typically, our readings are going to, well, they're going to be less than 29.92. They're going to be below 29 and to 28. Okay. All right, so this is a visual that you guys have seen several times when we talk about high pressure. So you'll notice right here, here is our high pressure. So as air is cooling, it's going to become more dense and it sinks and it's spinning clockwise. So it's heading towards the Earth's surface, spinning clockwise. That's your high pressure system. A low pressure system, which is denoted with the red or the red L, is where warm airs, it's going to become less dense, it's going to rise, and it spinning counterclockwise. So low pressure systems, that's where we tend to get a lot of our stormy weather. High pressure air is cooling down and sinking towards Earth's surface, so it's coming down cooler. Warm air is rising, which is creating that weather pressure up in the, or that weather system up in the atmosphere. Okay, so you need to be able to recognize the difference between these two. When I have air coming down, that's creating a high pressure system. When I have warm air rising, it's creating a low pressure system. So, high pressure system, when we have a high pressure system, typically the weather is going to be very sunny. You're going to have clear skies. You're going to have calm winds. It's not going to be very windy. And if they are windy, it's going to spiral clockwise. The air is dry. Um, and then the mercury is going to be, the pressure is going to be around 30.5 inches of mercury. So this is what a high pressure system would look like on a weather map. A low pressure system is going to have cloudy, stormy skies. The winds are going to be very strong. They're going to spiral counterclockwise. So winds in high pressure system are going to be moving this way. Winds in low pressure system are going to be moving the opposite direction. The air is warm, moist air, and that's where we get those precipitation is because we have that moist air versus in a high pressure system where there's dry air. And then the mercury is not going to be around 29. It's going to be lower. It's going to be around 28 inches of mercury. Okay. We can, when you look at a weather map, you will see weather maps sometimes that look like this that have isobars in them. And so an isobar is a line that connects atmospheric pressure. So any point along that line is going to be the same atmospheric pressure. So if I take this line right here and I follow this line down and I go into New Mexico, the atmospheric pressure here in New Mexico is going to be the same atmospheric pressure that it was in Canada. We measure these millibars. So if you take a look at your maps here, you'll notice that I have millibars readings. Here's 1016, 1024, 1004. So here's a low pressure system because of the millibar reading. And then 996, there's a low pressure system. A high pressure system is, if you'll notice right here, is 1032. Okay. So 1 millibar is going to be about 29 hundredths inches of mercury. And so that's the difference between our reading. It just depends on the reading. So isobars are going to be in millibars, but barometers typically will give you either in millibars or in inches of mercury. Okay. So when we look at low pressure systems in storms, there happens we can get tornadoes and we can get hurricanes, and we'll actually be spending some time in our next unit looking at hurricanes, or our next exploration will be on hurricanes, and then we'll do a little bit of a tornado lab as well. So the pressure in a tornado, you'll notice this is a very, very low pressure because our average pressure is around 29. A stormy pressure is around 28. This is 25.17 inches of mercury or 850 millibars. Hurricanes, their average pressure is going to be around 882 millibars or 26 or right around 26 inches of mercury.